Finding the equation of a line tangent to a trigonometric function. So in this video, we're just going to do a quick example of how we can find equations of lines tangent to a trig function. Because we've already talked about how to do this with polynomials and other type of family functions. Now we're just tacking on the trig functions. So here we want to find the equation of a line tangent to f of x equals 4 cosine of x at x equals negative pi over 3. So we are trying to find the equation of the tangent line, so we can start out with our formula. Y minus y sub 0 is equal to m times x minus x sub 0. And this is the point-slope form of a linear line. So the two things that we're going to need to figure out are the point, and then we are going to have to figure out the slope. And we'll do that on the side work here. All right, so for the point, we are looking for x sub 0, comma, y sub 0. We are told that in our equation that x sub 0 is going to be negative pi over 3. And we know that to find y sub 0, we can just plug x sub 0 into our function. So we're trying to find f of negative pi over 3. Well, what is negative pi over 3? How do we find that on the unit circle? Well, remember our trick for negative angles is to add 2 pi, or add 1 full rotation to find its reference angle. So that means we're really looking for f of 5 pi over 3. And then we can plug that in, so we're going to get 4 cosine of 5 pi over 3. And let's see, if we remember our unit circle, cosine of 5 pi over 3 is 1/2. And 4 times 1/2 is 2. Which means the point that we're going to be working with is negative pi over 3, comma, 2. All right, next up is the slope. And let's remember that the slope is equal to the derivative of our function. So first thing we need to do is we need to take the derivative of 4 times cosine of x. Well, remember the coefficients stay alone, and the derivative of 4 is going to be negative sine of x, which means our formula to find the derivative at any point on our function is going to be negative 4 sine of x. But we don't want the derivative at any point. We want the slope at negative pi over 3. And again, we don't like negative angles, so we'll have to use our 1 full rotation trick to find its reference angle. So we're really looking for the derivative at 5 pi over 3. So we'll plug that in. We will have negative 4 sine of 5 pi over 3. And if we remember back to our unit circle, sine of 5 pi over 3 is negative radical 3 over 2. Well, let's see, the negative times the negative will cancel out. And 4 times radical 3 will be 4 radical 3 divided by 2, which can be simplified down to be 2 radical 3 as our slope. And now that we have all the pieces, we can go and substitute them into the equation of our tangent line. So we're going to get y minus, we found out that y sub 0 is 2. That's going to equal our slope, which we found out was 2 radical 3. And then times x minus our x sub 0, which is negative pi over 3. All right, and we can simplify down. Negative times a negative is going to be a positive. So we're going to have y minus 2 is equal to 2 radical 3 times x plus pi over 3. And now if we wanted to write this in slope-intercept form, we'd have to get the y by itself. So we'll add 2 to both sides, leaving us with y is equal to 2 radical 3 times x plus pi over 3 plus 2. And then we can take the 2 radical 3 and distribute it in, and we're going to get a pretty, or a not so pretty, linear function. 2 radical 3x plus 2 radical 3 pi over 3, and then plus 2. And now we really can't combine any other terms here because 2 radical 3 pi over 3 is a pi, and 2 doesn't, so that is where we can leave our answer. All right, folks, and that is it. That is finding the equation of a tangent line to a trigonometric function.